Today, when we use a computer, we have to learn the computer's language. But it should be the other way around. The computer ought to learn our language to converse with us. And towards this human language, computing is a really important component. How do we teach computers and intelligent devices of the future to learn to talk to us, to see us, to communicate with us using our language? The Chinese language has over 6,000 characters, or alphabet if you will, and our keyboard has only 26 keys. And how do you map this 26 keys to 6,000 characters? In our efforts in keyboard-based inputs, we're dealing with using phonetic inputs called pinyin to convert into Chinese characters. That conversion process is not straightforward because there are many characters for each pinyin symbol. We're building a very powerful statistical language model that can look at the whole sentence essentially and reason which pinyin should map to which character that makes the most sense in the Chinese language. We're also working on designing a very good user interface. We have a what you see is what you get way of doing input. So as you type, the pinyin characters show up until the system is certain about the Chinese characters. When it makes an error, we make the error correction incredibly easy. We have an in-place error correction technology that allows you to see all the alternatives that scroll as you hit the arrow key, and the user can visualize the entire sentence as he or she corrects the errors. The system can automatically separate Chinese pinyin from English. You just keep typing those letters of the alphabet, and the system will convert those that are pinyin to Chinese characters and leave those that are English as English. We believe for the next 2 or 3 years, keyboard input will remain dominant, and we want to help perfect the current keyboard input methods. But we also think that speech is the most natural form of human communication, and we can talk much faster than we can type. So we've developed a Chinese speech recognition system that has the state-of-the-art accuracy and also speed that we think over the next 3 years or so can become a mainstream way of doing input for Chinese people.
我们来到商店，逗号，买了一本书。
Speech recognition will convert any spoken text by any user into Chinese characters.
为什么还这么重视挖掘？
It's built on the same language model as the pinyin system, so the user can use speech and keyboard interchangeably. That's actually very important because for most end users, they don't necessarily always want to use speech or keyboard. In some situations, speech may be perfectly good, but if you're in a meeting or sitting in an open office, then a keyboard is better. So we want to make sure that the speech and the keyboard input have a consistent user interface and can be used interchangeably. Today we have keyboard and speech solutions for Chinese input. But thinking longer term, we believe that just as the American or English computer evolved from needs of the American or Western people, we think a computer could be designed that's particularly suitable for the Chinese people. And this computer could also be applicable to all of Asia and eventually the rest of the world. And that maybe someday we'll all be computing without keyboards wherever you are in the world.